So by now you understand why we are using LangChain, right? Because by using LangChain, we are able to build end-to-end generative AI applications by using the methods that are provided by LangChain, right? So that's why we are trying to learn all the different components of LangChain, right? So we have seen how to load a document by using document loaders and how to chunk the input document, and then how to create embeddings for these chunks and how to store these embeddings inside a vector database. And we have also seen prompt engineering, right? So asking the right question to the LLM so we can get the right answer. And now in this lecture, let's learn about memory, right? Tools, agents and chains we will cover in the coming lectures, right? So now you get the idea. Now let's learn about memory, right? So all we are trying to do is we are trying to empower LLM and trying to build an end-to-end generative AI application by introducing all these different components, right? So what is memory? Memory is the ability for an LLM to store information about the past conversations, right? So think about the human brain, right? We as humans can process a lot of information, but sometimes the action that we take in the present is based on the past information, right? For example, let's say you are in a conversation with somebody and you introduced yourself to each other, and after a while you need to address the person's name, right? So in order to do the real conversation, you need to have the memory, right? So for example, let's say you are building a chatbot application, right? You need to have the memory component ready because the LLM should be able to retain the context and remember the previous conversations, right? So let's say you are doing multiple conversations with an LLM. This is human, that is you, and the AI is responding. And then again human, we are asking some question and then AI is responding. And then again human is asking some question and then LLM is responding, right? So this is how you are trying to chat with an LLM. So which is nothing but a chatbot, right? So in this case, the LLM needs to retain the memory of these conversations in order to respond, right? But what are some of the problems here? We already learned each LLM has a fixed context window size, right? So we know the context window is nothing but the input plus output together. That is whatever the question that we are asking plus whatever the LLM is responding together, the total number of tokens, right? So this is for one conversation. And as we introduce more conversations, then it may not work once we reach the context window size, right? That is, as we introduce more questions, then at some point it will reach the final token number, right? Then the LLM may not be able to work. Then we will lose the entire information, right? Then the LLM might ask you to start a new session or a task, right? So we have two problems here. One is the context window size limitation, and then the second problem is once it reaches the final token number, it may not be able to retain the context and we will lose the information, right? So let's see the memory implementation so you understand better, right? And we will cover implementing conversation buffer memory, conversation buffer window memory, conversation summary memory, and finally I will show you how to deep dive into other memory types, right, by going to the LangChain documentation. So let's learn how to implement these memory types in the next lecture. All right, thank you. So we understood what is memory, right? So memory is nothing but the ability for an LLM to store information about the past conversations, right? So as I mentioned, we have different types of memory: conversation buffer memory, conversation buffer window memory, conversation summary memory, and several other types available, which we will go through. So now let's see how we can give memory to an LLM by using conversation buffer memory, right? So as the name suggests, the LLM keeps the entire conversation history in the memory, right? So that means it stores every single conversation in the memory. So when we have lengthy conversations, we will lose the context after some time because of the context window limitation. Or once it reaches the maximum token, then the LLM may ask you to initiate a new task or session, right? And the drawback with conversation buffer memory is it passes the entire conversation history, right? That is more context window, so more GPU processing, so more tokens and more money, right? So let's go to VS Code and start building the project and see how we can give memory to LLM by using conversation buffer memory, right? So this is our build generative AI applications workspace, and underneath we created several projects here. So we have seen RAG, chunking methods, prompt engineering, document loaders, right? Now let's see memory, right? So here I've created an empty folder and I named it memory demo, right? So let's add this folder to our workspace, build generative AI applications, right? So come to the Explorer and right click, add folder to workspace and select memory demo and add. Click yes, right? So now we got the memory demo folder added to our workspace, right? Now, so make sure you select this folder and then file, new file, Python file, and let's try to save this file and make sure you go to memory demo. Let's try to save this file as conversation buffer memory demo and save, right? So the first thing is, let's try to import all the required packages from LangChain, right? So here you have to install LangChain Anthropic. If you already installed, you don't have to install this again. We have used this Claude Anthropic already in our RAG application, right? If you have already installed here in our RAG project, you don't have to install it again. If you haven't installed already, make sure you install LangChain Anthropic. So we will be using Claude Anthropic, right? So instead of Claude Anthropic, you can use OpenAI as well, right? Or instead of these paid LLMs, you know, Anthropic is paid LLM and also OpenAI is paid one, right? So instead of these paid LLMs, you can also use any other open source LLMs as well, either from Hugging Face or Olama. So we have several other open source options as well. And as you know, LangChain is model agnostic framework. That is, you can use any model and the LangChain supports that model, right? So you do not have to rely on just one model, right? So what we did here so far, we imported all the required modules from LangChain. First one is Chat Anthropic, because we will be using Anthropic LLM and we will be chatting with that. So that's why we imported Chat Anthropic, and then conversation chain and conversation buffer memory. And these two are to load the environment variables, right? So we will be storing our Anthropic API key inside the environment variable, and we will be loading the environment variables from the environment file by using load_.env and using it in our code, right? So first thing is, let me try to create an file and let me name it .env, and inside this let's try to store our Anthropic key, right? So you have to store your key. And when we were implementing RAG application, I've already shown how to get the API key from Claude Anthropic, right? So make sure you store your key here. Okay, let me close this. So far what we did, we installed all the required packages and then we loaded the modules that are required from LangChain, right? And also we created an environment file and stored our API key over there. And we will be using Claude Anthropic. Instead of Claude Anthropic, you can use any other LLM as well. Okay. So first thing is, let's try to load the environment variables from the .env file, right? By using load_.env function. And once we load the environment file, next thing is, let's try to read the key. This is the name we saved inside the environment file. So we are trying to read the API key by using getEnv function, and we are assigning to a variable called Anthropic API key. So let's close it here. And now this Anthropic API key, let's assign this to environment variable, which is nothing but Anthropic API key, right? So with this, we are able to load environment variables from environment file, and then we read the API key and we stored inside our environment variable Anthropic API key. Okay. Now next thing is, let's set our LLM. So we will be using Claude Anthropic, right? So let's try to initialize the LLM. And here we are using Chat Anthropic, which is from LangChain Anthropic. And the model is Claude 3.5 Sonnet. So that is our LLM. So with this, we initialized our LLM. So our LLM is ready to chat. So instead of Chat Anthropic, you can use any other models too, right? So you don't have to just use Claude Anthropic LLM. Instead of this, you can use Chat Olama, right? If you want to use Olama model, then you can replace this chat Anthropic with chat Olama, right? So go to Google and type chat Olama, right? And then click on this. So you can see we have the support from LangChain, right? So all we have to do is install LangChain Olama package. Once you install the package, then you can make use of this chat Olama module, which is inside LangChain Olama package, right? So this is how you can use open source LLM, which is nothing but Olama, right? Or if you want to use OpenAI, right? So go to Google and type chat OpenAI and click on this LangChain URL, and then here it shows how to install the package. So pip install LangChain OpenAI. Once you install the package, then you can get chat OpenAI module, which is from LangChain OpenAI, and you will be able to initialize the LLM, right? And make sure you import the corresponding packages, right? So all we have to do is we just have to change this one line if you want to use any other LLM, right? And the rest of the code will be as is. So we have our LLM ready. Now the next step is we want to give memory to the LLM, right? It is so simple here. You just have to write one line, and that is the advantage of using LangChain. So how can we provide memory to LLM? So here we are using conversation buffer memory, right? This conversation buffer memory we are getting from LangChain Memory, right? And if you want to see the documentation of conversation buffer memory, so you can just go to Google and type conversation buffer memory and go to the LangChain documentation. So if you notice here, underneath memory, we have different types of memories, right? Conversation buffer window, and conversation summaries. So we will implement few types, and then you can deep dive depending on your requirement, right? So you have the documentation here, you can go through. So with this, we added memory to the LLM, right? Now, once we have the LLM ready with memory, now the next step is we need to wrap both LLM and memory by using this chain, right? Here we are using conversation chain. So by using conversation chain, we are passing 3 parameters. The first one is memory. So memory we've already created here, and the LLM we already initialized here, and verbose is equal to true. So this is how we wrap both memory and LLM by using conversation chain. We are trying to bind the LLM with the memory by using conversation chain. So what is chain? Chain will help you to do multiple complex tasks together. So more on chains we will discuss later. We have a separate section where we will deep dive into chains, right? So this conversation variable here is the chain that we have created, which has LLM and also memory, right? So we have an LLM which is Anthropic, and this LLM has memory, right? So once we bind both LLM with memory by using chain, now we are ready to start the conversation with our LLM, right? So let's try to chat with our LLM. So inside conversation buffer memory, we have a method called predict, and for this we are passing input is equal to hi, my name is Mala, right? So this is how we are trying to chat with our Anthropic LLM. So let's try to save this code and click on run Python file. So here you can see entering new conversation chain, prompt after formatting. Always look for the current conversation, right? So human, hi, my name is Mala, and this is how AI responded. Hello Mala, it's a pleasure to meet you. My name is Claude and I am an AI assistant. I am always excited to chat with new people and learn about their interests and experiences. Is there anything in particular you would like to talk about today? I would be happy to discuss a wide range of topics from science and technology to arts and culture. Or if you prefer, we could just have a casual conversation and get to know each other better. Please let me know what you would enjoy, right? So this is our input human, and this is how Anthropic responded, right? So what we are trying to do here, we installed all the required packages, and then we imported the modules, and then here we tried to load the environment variables from the environment file, and we got the key and we stored inside our environment variable, and then we initialized our LLM by using chat anthropic, and then we created the memory, and then we tried to bind the LLM with the memory by using conversation chain, and then we are trying to chat with our LLM. The first conversation is, "Hi, my name is Mala," and this is the response we got from LLM after executing. So here the current conversation is nothing but memory, right? So always look at the current conversation. Human means it is me, and AI is nothing but Claude Anthropic. So this is our first conversation. First conversation means I have asked something and the LLM has provided the response. So conversation means both the question that we asked and also the response that we got from the LLM, right? Question and response together is called conversation. And second conversation means again I've asked a question to LLM and the LLM has responded, right? So this is our first conversation with our Claude Anthropic LLM. Now let's try to do another conversation, right? So let's try to ask another question. So inside conversation buffer memory, we have a method called predict, and we are passing the input as "I'm doing well, just having a conversation with an AI," right? So let me save it and let's rerun the code. So this is what the LLM responded for the second question, right? So if you notice here, this is our current conversation, right? Now you can see the LLM retained the first conversation history as well. So this was our first question. "Hi, my name is Mala," and this is what LLM responded. And this is our second question, right? And then this is what LLM responded for our second question. So that means it is trying to retain every single question and the corresponding answer, question and the corresponding answer, right? And now let's try to ask third question, what is AI, right? So let's try to rerun the code. So this was our first question, and this is what LLM responded, and this is our second question, this is what LLM responded, and this is our third question, what is AI? This is what LLM responded for our third question. So which is nothing but what is AI, and this is what it is responded, right? So that means for every single question that we ask, it is trying to retain the previous conversations as well, right? So here we only asked 3 questions, right? As we are having more conversations with the LLM, that means we are using more tokens, right? So the context window is nothing but both input and the output response together, right? The total number of tokens, right? That means the entire conversation will be converted into tokens, and the problem here is the LLM is trying to remember the entire history, right? Not just the current question. It is trying to remember the entire conversation history. So which means we are using more tokens. So that means more GPU processing, so more cost, right? Now we have asked, "Hi, my name is Mala, I'm doing well, just having a conversation with an AI." What is an AI, right? Now, what is the proof that our LLM, Claude Anthropic, is remembering, right? So we have added this memory, but what is the proof that our LLM is able to remember what we have told, right? So the first conversation, what we said, "My name is Mala," and we did 2 other conversations. So after having few conversations, now let's try to ask, "What is my name?" right? To test if the LLM actually remembered the context or not, okay? So this is what we are trying to pass. The question is, what is my name, right? So let me try to rerun the code. So whenever you rerun, right, so always look for the current conversation, right? So the first question and answer, second question and answer, and third question, what is AI and answer, what is my name? So you can see your name is Mala. If you see here, your name is Mala. You introduced yourself at the beginning of our conversation and I made sure to remember it, right? So the LLM was able to remember the name because we added memory to our LLM, right? So this was our first conversation, and after that we did 2 other conversations. Finally, we are testing LLM if it actually remembered our name or not, right? So after few conversations, it still remembered, right? So this is nothing but memory, right? So what is happening with conversation buffer memory? As the name suggests, this is trying to keep the entire conversation history in memory, right? Because we asked 4 questions and it tried to keep the, if you see the current conversation, so this was our first question and answer, second question and answer, right? And then third question, what is AI, and the corresponding answer. And finally, what is my name? That is the fourth question and the answer, right? So what is happening here? It is trying to keep the entire conversation history in memory to help contextualize the answer to the next user question, right? So while this sounds very useful, only drawback here is that it keeps all of the history, right? So up to the maximum limit of specific LLM, right? We know each LLM has a fixed context window size, right? And for every question we asked, it tried to pass the whole previous discussion, right? That is, it is more tokens to the LLM API, right? So this can have significant cost impact, right? Because API costs are based on the number of tokens processed and also the latency impact as conversation grows, right? Because here we used 4 conversations and this is how it created, right? So you know this will be converted to tokens and processed, right? So that's about conversation buffer memory. So let me quickly summarize. So first what we did, we installed all the required packages and then we imported all the required modules, and here we used Claude Anthropic as our LLM. Here we loaded our environment file and read the API key, and we initialized our LLM by using Chat Anthropic, and the model that we are using is this. And the next thing is we added memory to our LLM by using conversation buffer memory, right? Once we have the memory and LLM, we try to bind LLM with the memory by using conversation chain. And conversation chain we imported from LangChain chains. And once we have the conversation chain ready, we started our conversation with Claude Anthropic LLM, right? The first question is, hi, my name is Mala, and the LLM responded. And the second question we asked and LLM responded. Third question and fourth question, finally we tried to test the LLM if it actually remembered the name or not, right? Which is nothing but the memory, right? We told LLM to remember the conversation because at the beginning we introduced the name as Mala. It tried to remember it and try to respond the name as Mala, right? And the only drawback with this is it will try to keep the entire conversation history for each and every question, right? So that means more tokens and more GPU processing and more money, right? And at one point, once it reaches the maximum limit, then the LLM may not be able to respond anymore, right? Because the LLM might ask us to initiate a new session or task, right? With that, we may lose the context as well, right? So that is one of the disadvantage of using conversation buffer memory. So with this, I hope you are clear on how to initialize an LLM, how to add memory to an LLM, and how to bind LLM with the memory by using conversation chain, and how to start doing the conversations with an LLM. All right. Thank you. So we are trying to learn how to give memory to an LLM, right? So we have seen the first type, that is conversation buffer memory. And now the next one is conversation buffer window memory, right? So let's go to our VS Code and try to implement by using conversation buffer window memory, right? So we've already seen conversation buffer memory. And the problem with the conversation buffer memory is that the LLM is trying to store every single conversation in the memory, right? So that means more tokens and more GPU processing. And as we know, we are charged by the number of tokens usage, right, for each API call, right? So for example, here we only asked 4 questions, right? So let's say you asked 100 questions, and is it really necessary for an LLM to remember all the previous 100 conversations? That is 1 to 100? No, right? So to address the problem of storing every single conversation, what is the solution here? As an user, you can decide and tell the LLM that you only want the LLM to remember only specific conversations, right? So you can define by using a index parameter called K. So in our conversations, we do not usually need to remember all the conversation histories, right? But definitely the last few conversations. So here we only used conversation buffer memory, and the next one is conversation buffer window memory. We can define the parameter k, and we can tell the number of last few conversations the LLM should remember, right? So it simply tells the LLM remember the last few discussions and forget all of the rest, right? For example, let's say if you give k is equal to 7, that means the LLM will try to remember only the last 7 conversations, right? And let's say if you give k is equal to 1, meaning the LLM will only remember the last conversation, right? So now let's try to see the second one, conversation buffer window memory, right? So let's go to our memory demo and click on file, new file, Python file, and let's try to save this as conversation buffer window memory demo and click on save, right? So let me close this. So let's try to use the same code. So instead of conversation buffer memory, we will be using conversation buffer window memory, right? And then we loaded our environment variables from the environment file, and we read the key and we stored inside our Anthropic API key. And this is how we initialized our LLM, and we are using Claude Anthropic, right? And the next thing is we need to give memory to our LLM, right? And here we will be using conversation buffer window memory. So the next step is we want to give memory to the LLM by using conversation buffer window memory. And here we are saying the number of messages to store in buffer, right? So we are telling k is equal to 1. That means we are telling the LLM to remember only the last conversation, right? So let's say if you give k is equal to 10, then the LLM will try to remember the last 10 conversations and it will ignore the remaining, right? And inside conversation buffer window memory, we have a function called save underscore context, and that will be used to save the context from this conversation to buffer, right? So let me quickly go to LangChain, and from here we have a search option. So let's try to search for conversation buffer window, and if you see here we have save underscore context function, right? So let's try to use the function from conversation buffer window memory. We have a function called save underscore context, and by using this save underscore context, it will try to save the conversation to buffer, right? So if you notice here we have input and output. So input means the human input and output means the AI output, right? So whenever you say hi, then you want the LLM to respond as what's up, right? And similarly, let's try to add one other memory dot save context input as not much, you output you want the LLM to say not much, right? And then let's try to load these memory variables, right? So this is a sample example, but let's say if you're trying to build a chatbot, right? And whenever the chatbot is conversing, we want the chatbot to remember, for example, let's say the company name, right? So input is the company name and output is some ABC company, right? So you are telling the LLM to remember the company name as ABC, right? And let's say if you want the LLM to say welcome to ABC company, right? And instead of writing that ABC every time, you are just storing it here. We are saying input as company and output as ABC, right? So that the LLM will remember whenever the user says company, then the LLM will replace that with ABC, right? So you can keep the data inside this dictionary so the LLM can remember that data, right? So if you have any kind of information you want the LLM to remember, then store them by using this save underscore context method, right? And here input means human input, output is nothing but LLM's respond. If you are saying hi, you want LLM to respond as WhatsApp. If you are saying not much, then you want the LLM to say as not much, right? For example, let's say you are building a chatbot application, right, for your human resource department. So whenever the human tells us what is the link for downloading the payslip, right, then you want the LLM to provide some URL, right? So for the payslip, you can provide the URL www.xyz.com, something like that. So you can provide the URL of your payslip, right? So that is the advantage of using this save context and save context from this conversation to buffer, right? So now let's try to create conversation chain with memory LLM, but we are using conversation buffer window memory, right? So we are telling the LLM to remember only the last conversation, that is k is equal to 1, right? And then let's try to bind the LLM with the memory by using conversation chain. Once we have the conversation chain ready, let's start the conversation with Claude Anthropic LLM, right? So our first conversation is, hi, this is Mala, right? So now let's try to run this. And if you see the response here, this is our current conversation, right? Hi, this is Mala, and the LLM responded as, hello Mala, it's nice to meet you, and this one, right? So here we have only one conversation so far, right? So let's ask one other question, and this is our second conversation. 2 times 2 is 4, right? And now let's save it and run the code. If you see the current conversation, this was our first question and this is the answer, second question and this is the answer, right? You are absolutely correct, Mala. 2 times 2 does indeed equal 4, right? And now we gave k is equal to 1. So that means the LLM will try to remember only the last conversation, which is 2 times 2 is 4. And it will not remember the name, that is Mala, right? So now let's try to ask the third question. What is my name, right? So now let's run the code. So if you notice here, the response of the LLM, I apologize for the confusion in my previous response. I made a mistake in addressing you as Mala. That was not correct. In fact, I don't actually know your name, right? So we have provided this and then we did the second conversation and this is the third conversation, right? So by now the LLM has forgotten because we have provided k is equal to 1. So that means the LLM only remembered the last conversation and it forgot my name, right? So k is equal to 1 means it will only remember the last conversation and rest of the conversation will not be remembered. It will be ignored, right? So here k is an user defined parameter, right? You need to define this parameter as per your need. Let's say you do not need LLM to remember any prior conversations, then you go for conversation buffer window memory, right? So at least with this, let's say if you have 100 conversations and if you don't want the LLM to remember all the prior 100 conversations, and if you want the LLM to remember only the last 5 to 7 conversations, for example, then you can define the index parameter as 5 or 7, right? So that means we are using less number of tokens, right? Even with this, at one point, it might reach the maximum LLM token limit, right? So in that case, again, we will lose the context and the LLM might ask us to initiate a new task or a new session, right? So in that case, we will lose the entire context, right? Here we only use few questions, but in real time we may have several questions, right? So at one point, we might reach the maximum limit and we might lose the entire context, right? So that is another disadvantage of using conversation buffer window memory, but at least you can specify the index parameter and tell the LLM how many number of conversations you want the LLM to remember, right? I hope this is clear. So all we are doing here is we installed all the packages and loaded our required modules, and we read the key and we initialized our LLM, and then the next one is memory, right? Here we are using conversation buffer window memory and we are telling the LLM to remember only the last conversation, and then we use the conversation chain to bind our LLM with the memory, and then we started our conversations. This was our first conversation and second conversation, and then in the final conversation we asked our LLM what is the name, and it forgot because it only remembered the last conversation because we gave the index parameter k as 1, right? So that's all about conversation buffer window memory. All right, thank you. So far we have seen what is memory and what are the different types of memory, and we have seen the implementation of providing memory to an LLM by using conversation buffer memory. and conversation buffer window memory. Now let's see how we can provide an memory to an LLM by using conversation summary memory, right? So let's go to our code editor, VS Code. So we can see the implementation here, right? So we have seen conversation buffer memory, and the second one is conversation buffer window memory, right? Now let's see conversation summary memory, right? So click on memory demo, file, new file, Python file, and let's save it as conversation summary memory demo. The conversation summary memory, as the name suggests, it will try to remember the summary of the conversation and try to answer by using that summary, right? So we can retain the context by summarizing the content. And if we summarize and store, we will be using less number of texts. That means less number of tokens. And we will not lose the context like either conversation buffer memory or conversation buffer window memory, right? Because either in conversation buffer memory, we are trying to store every single conversation here, and with the buffer window memory, we are trying to store at least few number of conversations, right? So we are trying to store the exact conversations, but whereas with conversation summary memory, it will try to summarize the content and will try to answer from the summary, right? So at least conversation summary is better than conversation buffer or conversation buffer window, right? Now let's see the implementation part. So let me copy the same code until LLM initialization, right? So I'm copying the same code, and instead of conversation buffer window memory, we will be using conversation summary memory, right? So here we installed all the required packages, and then we imported the modules, and then here we are trying to load the environment variable and read the API key and store it in environment variable Anthropic API key. Here we are using Anthropic LLM, right? And this is the model we are using. So this is clear so far. So now let's try to create a long string and see if the LLM can summarize the text, right? So this is our text, and we are assigning this to a variable called schedule. And our text says there is a meeting at 8 a.m. with your product team. You will need your PowerPoint presentation prepared. 9 to 12 p.m. have time to work on your LangChain project, which will go quickly because LangChain is such a powerful tool. At noon, lunch at the Italian restaurant with a customer who is driving from over an hour away to meet you to understand the latest in AI. Be sure to bring your laptop to show the latest LLM demo, right? So this is our text. Now, next step is we want to give memory to the LLM, right? By using conversation summary memory. So we used conversation summary memory and we passed the LLM. We already initialized the LLM, and the max token limit is equal to 100. And then inside conversation summary memory, we have a method called save underscore context, which we have seen already with conversation buffer window memory, right? Memory dot save context, input is equal to hello, output is equal to WhatsApp. If user says hello, you want the LLM to say as WhatsApp, right? And similarly, let's add one more. Input is not much, just hanging. If the user says this, you want the LLM to say cool, right? Now let's try to add one more. If the user says what is on the schedule today, then you want the LLM to respond from this schedule, right? So the schedule is we have already defined with this text, right? Now let's try to load these variables by using inside conversation summary memory. We have a method called load memory variables, right? So here this schedule, it is a long text, right? And the max token limit is 100, and if you do not specify this limit, then it will take the limit of the LLM, right? We know each LLM has its own maximum token limit, right? So in this case it is Claude Anthropic. Whatever the token limit is there, it will try to take that one. Otherwise here we are trying to specify the maximum token limit as 100. So in this case it will consider 100, right? And inside conversation summary memory, we have a function called save underscore context, right? So inside save underscore context, you can try to save the question answers that do not change, right? For example, let's say you can give the URL for onboarding document, or maybe payslip URL, or your company's 10K report, right? That is what is onboarding URL, and then you specify the URL. And what is the URL for payslip, and here you specify the URL. Or if the user says, how can I download our organization 10K report, then you specify the URL here, right? So for any question, if the answer is not changing, then in that case you can just try to save. You can use save_context and try to save that, right? So what we did here, we installed the required packages, and then we loaded the modules, we read the key and stored here, and this is how we initialized our Claude Anthropic model, and then we created a long text. This is our long text, and we are using conversation summary memory, and here we are passing our LLM, and we are assigning the max token limit as 100. And by using save_context, we are trying to store these variables, right? This is a dictionary, right? So if the user says hello, we want the LLM to say WhatsApp. Not much, just hanging, then you want the LLM to say cool. What is on the schedule today? Then it has to summarize from this context, right? So now let's try to print this and see. So let's run the code. So now you can see here is the new summary incorporating the additional lines of conversation, right? So what is it trying to say? This is the response from AI, right? So here is the new summary incorporating the additional lines of conversation. The human greets the AI and the AI responds casually, right? So what does that mean? The human says hello, the AI says what's up, right? The human indicates they are not doing much, just hanging out. So this one, and the AI acknowledges this with a brief, cool response, right? The human then asks about the day's schedule, right? So that is what we are trying to ask. The AI provides a detailed itinerary, including an 8 a.m. meeting with the product team requiring a PowerPoint presentation. So that means this schedule, right? So it is trying to summarize this text. Time allocated for working on a LangChain project from 9 to 12, right? So that is what we are doing from 9 to 12, right? And a lunch meeting at an Italian restaurant with a customer interested in AI, right? So that is what we are trying to do at noon. Advising to bring a laptop for an LLM demo, right? So this is our long text, and this is how our Claude Anthropic LLM summarized, right? You can see it summarized the lengthy conversations, right? So here you can replace this text with any other text and see how the LLM is summarizing, right? Now let's try to use this conversation chain. So let me minimize this. So now by using this conversation chain, let's try to bind both memory and LLM, right? Which we have seen already. So use the conversation chain for memory, assign memory variable, and for LLM we have already initialized, so assign that and verbose is equal to true, right? So once we have the conversation chain ready, let's try to ask another question by using predict, and here we are trying to pass 9 to 12, what will you do, right? So it should answer based on the summary from the long text, right, which is stored inside schedule variable, and we have already seen it already summarized, right? So now let's see if the LLM will be able to answer for this question from this summary, right? So now let's rerun the code. So you can see the current conversation, and this is the updated summary. Then human, we asked 9 to 12 p.m. what will you do, right? So that is our question. And what is the response from AI? According to the summary provided, from 9 to 12, I will be working on a LangChain project, right? So that is what we have provided here. 9 to 12 p.m. have time to work on your LangChain project, right? And it's trying to give more information here. It's a substantial 3-hour block of time dedicated to this task, right? So for our question 9 to 12, what will you do? This is what our LLM is trying to respond, right? So the LLM was able to answer the question from the summary, right? So it summarized first, and then from this summary it tried to answer the question that we asked, right? Okay, So now let's try to ask more questions, right? So let's ask, what is deep learning, right? Now let's run the code. So you can see the answer from the LLM, right? Now let's try to ask one other question, right? What is AI? And then now let's try to, or let me kill this terminal, and then let me try to rerun the code. So let me scroll up. So if you notice here, this is the conversation, right? And then it tried to summarize, and then we asked a question and the AI responded. And then again we asked another question, what is deep learning? Here it tried to summarize about deep learning. And then if you scroll down, we asked, what is AI? Before this, it says the human then asks about deep learning, right? So what it did, it tried to summarize here, right? That is the advantage of using conversation summary memory, right? So for every single conversation, it is trying to summarize and try to append it to the answer, right? And the next question is, we asked what is AI, and then it tried to provide the answer. And if you ask one other question, then it will try to summarize the previous conversations as well, right? So by using this conversation summary memory, the conversation will be summarized and stored instead of the entire response, right? So that means it indicates less text, right? Which is nothing but less tokens. So this conversation summary memory, this is better than conversation buffer memory or conversation buffer window memory, right? Because in these two cases, we have seen it is trying to store every single conversation entire context, right? But whereas with conversation summary memory, the LLM is trying to summarize and then store, right? So that means less text, so less tokens, right? Even by using conversation summary memory, let's say if you keep asking more questions, it may fail at some point because we know each LLM has context window or token limitation, right? Here we specified the max token limit as 100. Once it uses all the tokens, then it may not be able to answer any further, right? But at least this conversation summary memory is better than the other two types that we have seen. So that's all about memory. So we have seen conversation buffer memory and conversation buffer window memory and conversation summary memory. You can try exploring other memories depending on your requirement, right? But you get the idea of memory, right? Memory is nothing but trying to give power to the LLM so that the LLM can remember the context, right? Now, if you want, you can deep dive other memory types which we have inside this LangChain, right? So LangChain supports these other memory types as well. So this is the official documentation, and depending on your requirement, you can try to deep dive, right? All right. That's all about memory. Thank you.